Presentation in charge of Dr. Jess Zimmerman. He's the lead principal investigator of the Luquillo Long-Term Ecological Research Program and professor at the University of Puerto Rico. He will be presenting the topic Impacts of Hurricanes on Forest Structure in Puerto Rico, a review.
Yeah, thank you, Adrian. Thanks, Joe, for that start. I'm a forest ecologist, so I'm going to be talking about forests, but as you well know, forest structure and dynamics has a lot to say about bird population dynamics and communities. And I can't. Oh, got the button. Okay. As you know, hurricanes, tropical cyclones occur around the world. Joe showed a nice picture of the Caribbean and all the tracks and storms that we've had. And we do have quite a high frequency of storms in our region, but there are other regions, particularly the Western Pacific, that are even more active. And I'm going to use this contrast to try and make some sense of what is happening to our forests during cyclonic storms and what may be happening in the future if these storms become more intense. Let's see, push the right button. Okay. As you know, we've had a number of storms come through Puerto Rico over the last 150, 200 years, for millennia, presumably. Most of them come right through the island, like Maria did, and Georges did. Hugo clipped the northeast corner of the island. One of the things that stands out about this, these are storms with significant damage. That is, they knock down trees, cause damage to buildings. They have damage on the scale of the Fujita scale of F2 or higher. This is from a publication that we have forthcoming in Ecosphere. One of the things that's interesting is that Irma was what I call kind of a drive-by storm, although there was significant damage in the northeast corner of the island. And I think what's going to happen in the future is we have more intense storms that are much larger, but some of these storms that are passing at a distance are actually going to become have significant impacts on the island. Using certain methods, Fred Scatina and Matt Larson, after Hurricane Hugo, estimated that we got storms like that every 50 or 60 years in the recent record. Nick Brokaw, using the same methods, updated that in 2017 after Hurricane Georges and Maria, and that return interval is now reduced to 39 to 44 years. And so the storms most recently become more frequent as been predicted. So using diagrams put together by H.T. Odom in the 60s and 70s, we can look at the long-term impacts of storms in different regions of the world, and maybe with an eye towards what's going to happen in the future. So in areas that don't have cyclonic storms, you have tall forests, lots of emergence, and so forth. In our regions, you tend to have shorter forests that tend to be kind of shorn off by the storms, but very dynamic. In other regions, and perhaps in the future, with more frequent intense storms, we'll have even shorter forests as a result. Or if you go to places like the Western Pacific, the Northwestern Pacific, you might see the same. In fact, you do. So first of all, to show some of these impacts, I'm going to use data collected by Nick Brokaw along the elevation gradient. If you're familiar with the Luquillo experimental forest, you know we have these kind of characterized forest types that go up the mountain, decline in height and productivity. And Nick Brokaw was able to capture the impacts of Hurricane Hugo on 3 of these forests, starting with Tabenuco at low elevation, Colorado at mid elevation, and Elfin at the summits. And one of the things that these hurricanes do, of course, is they remove much of the canopy and bring it to the forest floor, either by knocking down trees, but in many cases, just removing the branches. And this effect is most obvious in Tabenuco forest and Colorado forest, and less obvious in Elfin forest, which is another kind of truism that taller forests with greater structure tend to suffer more damage in hurricanes of a given intensity than shorter forests. And the same can be said of secondary forests as well. We can then take Tabenuco forest, this is at El Verde, and here The pre-storm hurricane structure is shown in the light bars throughout each of the graphs. And then we show how the canopy structure recovers beginning 2 months after the storm, 20 months, 40 months, and then to 61 months, 5 years after the storm. And what you can see is that the understory, what we're seeing now after Hurricane Maria, the understory starts regrowing. This grows up. Vegetation starts recovering at mid heights, and then eventually you begin the recovery of the forest structure. The result is that tends to shade the understory, and you get large amounts of mortality of the saplings that didn't make it to the canopy and the shrubs that came out after the storm. And your birds are, of course, responding to all of these changes in structure as well as food availability. Let me go back a second. Looking at the top of the canopy, that is taking the average of the highest measured level of the vegetation, you can look at canopy height over time. So before Hurricane Hugo and Tabenuco Forest, we had tall canopy, 20 to 22 meter forest. This was knocked back to under 10 meters after Hurricane Hugo. It struggled for a while, began to recover. And then you had Hurricane George, which knocked it back somewhat, but not as much. And that's largely because Hurricane George had similar meteorology to Hurricane Hugo, different trajectory, but there was less to throw around, and so it had less impact on the forest. And then the forest recovered again, and then of course it was knocked back very strongly by Hurricane Maria. Okay, so I'm going to look globally now and compare some of the patterns that we see in our forests to a worldwide pattern, comparing Panama, where you have no cyclonic storms, to two areas that have frequent cyclonic storms, the Philippines and Taiwan. And I'm going to look at understory mortality. This is mortality rate per year, percent of stems per year. And then these are forest dynamics plots that are the size. Ours is 16 hectares in Puerto Rico. They go up to 50 hectares in Panama. And these are recensused every 5 years. So there's a block of bars for every census. So we've now done 5 censuses. Panama had done 6 censuses at this time. And then over to the side, you see these are the size dimensions, or the size classes of the stems, from smaller stems to larger stems. And what stands out here, of course, is that the mortality rates of small stems in Puerto Rico, this is beginning after Hurricane Hugo, are much, much higher than any of these other sites, with some exception of some of the larger stems in the Philippines after hurricane, or they're called, not cyclones, typhoons there, Typhoon Zeb. And then of course you have very low dynamics in Taiwan, which sees these storms once every 4 or 5 years. The forests are knocked back constantly, and so they have very low dynamics. So there's kind of an intermediate disturbance argument going on here, suggesting that in regions like Puerto Rico, where you kind of had an intermediate interval between storms and the forest is allowed to recover quite a bit before the next storm, that you get large dynamics of the forest. So I'm going to continue on this theme. I'm going to go next to dry forest, where many of you know that Skip Van Bloon has worked on the forest in Guanica, showing that the hurricane response there is one of a lot of sprouting. I mean, we get a lot of sprouting in our forest, but there's a great deal of sprouting there. That's a big component of the recovery in that forest. And he did this worldwide comparison, showing that dry forests in the Caribbean, Bahamas, St. Lucia, and Puerto Rico, have much higher stem density, but much lower basal area than areas that don't have cyclonic storms. So again, showing that these cyclonic storms in the Caribbean, at least, have a strong effect on forest structure. Now I'm going to look at another thing related to structure, which is litterfall. And what happens in hurricane, this is litterfall over time in the Bees Lakes mineral watersheds, still Tabenuco forest, through different storms, including total litter and fruit fall. And I'll just talk about fruit for a while. After Hurricane Hugo, fruit production, as measured in litter baskets, was much lower for 4 years before it came back to something normal. And so that's another big impact that consumers, frugivores, are going to see, as well as well, frugivores in this case. But what I want to look at is the impact of the storms on when they impact the forest, they remove the structure, and that becomes debris on the forest floor, and we measure that in these studies. And so you can look at the effect size of the amount of litter that was knocked down in a storm compared to the average and call that the effect size. And then we can make a global comparison. This is a study being done by a postdoc at Barbara Blomfield, working at Berkeley with me and Laura Keppers, where she's collected data on the debris fall in hurricanes and other storms around the world. And then she's looked at this effect size as a function of soil phosphorus, which is what her interest is. She's interested in determining how soil phosphorus affects hurricane effects and recovery in the context of informing our global models of forest growth. And also, okay, I'm on the last slide. So, and also included in this model is wind speed. Taking those two factors out, you can still see this strong effect of the Caribbean region. Many Caribbean storms have much larger debris fall during storms than expected based on phosphorus availability and storm intensity. And so our forests tend to be somewhat different than other ones in terms of the impacts that these storms have on them. So there you can see that. And so there are my conclusions. You can read those as we maybe have some time to take some questions or move on to the next talk.
Thanks, Dr.